We are looking at a simulation of unstructured, autonomous AI agents attempting to build enterprise software. Without strict architectural boundaries, the agents lock into a tangled web of looping errors and compounding mistakes. Deploying AI models without explicit constraints leads to systemic failure. The system introduces severe scope creep, hallucinates non-existent libraries, and fails predictably at complex edge cases. Achieving predictable, autonomous execution requires re-architecting the SDLC into a rigid pipeline. The SDLC, or Software Development Lifecycle, is the structured process teams use to design, develop, and test high-quality software. Raw AI intelligence has zero value for enterprise engineering unless it is constrained by an invariant, deterministic architecture. This chart outlines the macro architecture of an AI-native SDLC. It operates across three distinct horizontal layers. The top layer allows for messy, highly iterative human requirements formation. In contrast, the middle layer acts as an invariant framework, governed entirely by rigid schemas and mathematical rules. This physical separation between human ideation on the outside and machine execution on the inside is the primary architectural defense against cascading AI hallucinations. Looking closely at the top layer, human stakeholders interact with an external requirements agent. The humans provide their goals and constraints, and the agent translates those desires into a formal artifact called an intake packet. The intake packet is a canonical, versioned document utilizing precise YAML or JSON. YAML and JSON are data serialization languages used to write configuration files in a cleanly structured, human-readable format. Once the external agent drafts the structured requirements, the intake packet moves to the strict internal boundary of the framework. Here it meets the gatekeeper. This sentry node is non-negotiable. It subjects the incoming packet to rigorous schema validation and automated ambiguity checks before any internal work is authorized. If the gatekeeper detects missing fields or ambiguity, it executes a rejection loop. It kicks the packet back to the requirements agent, along with specific instructions on what must be fixed. A flawlessly validated packet is the only condition that turns the gatekeeper green, allowing the structured document to pass through the boundary and enter the internal execution framework. Enforcing this strict schema ensures zero execution begins based on assumptions. Stripping out ambiguity at the gate eliminates the primary cause of AI drift. Inside the framework, the validated intake packet is handed to the orchestration executive, designated as the CEO node. The CEO's primary function is to analyze the requirements and generate the project org plan. The org plan acts as a project constitution. It manages the complexity budget by selecting the specific departments, tools, prompts, and verification gates required to build the software. Before it becomes active, a CTO governance node must review, modify, and officially approve this architectural layout. The approved plan is then routed to the Curator. Think of the Curator as the immutable flight recorder for the entire system. Logging the org plan to the Curator creates a permanent, tamper-proof audit trail of the project's foundational constraints. Establishing a restrictive organizational environment before defining a single line of code forces the subsequent AI agents to operate strictly within pre-approved, authorized boundaries. With the environment defined, execution begins. The CEO hands the finalized org plan and intake packet to the Dev Manager node. The Dev Manager translates the constitutional rules of the org plan into a concrete execution plan. This plan is formatted as a directed acyclic task graph. A directed acyclic graph is a mapping of tasks that flows explicitly in one direction without looping back on itself, establishing clear milestones. The Dev Manager splits the execution into multiple parallel workstreams to build the software components simultaneously. As the branches write code, a shared quality department continuously runs static checks and end-to-end UX tests against the active workstreams, feeding pass or fail data directly back to the Dev Manager. Simultaneously, a security department enforces threat models and security policy checks to catch vulnerabilities in real time. During execution, agents frequently encounter missing technical documentation. If an agent tries to fill in the blanks itself, it will compromise the build. To solve this, all internal nodes query a shared research department. This department provides versioned, factual context packaged as an evidence pack. The research department relies on RAG, or Retrieval Augmented Generation. This is an architecture that fetches external, verified documents to ground the AI's responses in explicit fact, preventing the agents from hallucinating technical solutions. Converting the org plan into a continuously verified parallel task graph replaces vague AI prompting with a highly deterministic factory floor pipeline. Even with rigorous planning and evidence retrieval, execution branches will inevitably encounter external roadblocks, like an undocumented API or missing dependencies. The backend branch detects critical missing information. It immediately halts progress and raises a formal issue to the dev manager. The system triggers a severity classification. The dev manager and CTO decide if this roadblock is a local or global failure. If classified as a local blocker, the dev manager pauses only the affected branch. The system perfectly preserves the backend's operational state while the frontend and database branches continue their work unaffected. The paused branch generates a resume packet. This document logs the exact blocker evidence into the Curator, allowing the specific branch to seamlessly restart the moment the missing data is supplied. If the CTO determines the issue is a global blocker, a foundational failure in the design, the dev manager halts the entire project task graph. A global blocker forces an amendment request back across the strict intake boundary. The system requires the human stakeholders to resolve the foundational ambiguity before any internal work resumes. Granular state management ensures that localized ambiguity doesn't crash the entire build. At the same time, systemic errors force immediate human alignment, rather than allowing the AI to improvise its way out of a problem. Once blockers are resolved and the parallel execution branches pass their final quality and security checks, they merge into the final delivery package. The dev manager node compiles the working codebase, any deferred clarifications, and the release runbooks into this final asset. At the moment of delivery, the Curator node serves its most crucial enterprise function. The Curator attaches the complete, immutable evidence ledger directly to the delivery package. This ledger provides absolute proof to enterprise architects. It catalogs every QA pass, security gate, and local blocker decision made by autonomous agents. The fully audited system is then passed back across the strict intake boundary to the human stakeholders. Achieving reliable autonomous software delivery requires constraining AI agents within a rigid, deterministic, and fully auditable organizational architecture.